Um, Good afternoon. So I will be discussing introduction to sketching. So before, in the previous modules and the previous PowerPoints, you've been discussing um, geometric constructions, you've been discussing lines and planes, and other shapes in 2Ds. Tapos nagkaroon din tayo ng konting introduction for other for 3D. Pero dito na tayo magsa-start formally ng 3D discussion natin ng drawing sa ES1. So, short introduction, I'm Cosner Jimenez, and I'm one of the professors in ES1. We're instructors, okay? So, in sketching, we will have 3 parts in our discussion, and first is we need to have an objective. This defines what we will be sketching. Dito rin malalaman kung ano ba yung goal natin for the sketching. And next is kailangan natin ng view. At ano yung gagamitin nating view for ES1. And ano yung mga pwedeng sketching techniques para sa discussion natin. And para paggagamit na kayo or gagawa na kayo ng plate. Okay? For an objective, maraming pwedeng reasons why you are doing a sketch. Maybe you're doing a sketch just to pass time. Sometimes it's the requirements sa school. Pero we could divide the objective or the motivation in doing a sketch into formal ways. First is if we want to convey information. Itong dalawang to, hindi naman sila exactly two opposites. Sometimes they overlap each other, but we could distinguish or categorize our purpose of sketching in these two ways. First is convey the information. Next is to express desires and emotions when we're doing sketches. Again, they're not polar opposites. Sometimes they overlap. And in engineering, we are more concerned with the first one. We want to convey information. Kasi yun yung goal natin sa S1. We want to create a sketch. We want to create an object that would be able to give the information someone else need when they are creating a chair or a table. Gusto natin ma-convey yung information about the chair or table or whatever we are planning to do. For expressing ideas naman and emotions, it's more of an art. It's more of, I'm not saying that we will not convey information through it, but essentially, those are the categories that we will be doing. So, ang goal natin kapag magawa tayo ng ES1 is to be as clear as possible when we're conveying information. To be as clear as possible para malaman agad nila. So, to be able to do that, we want to know standards. We want to be clear in our drawings. We want to be neat and organized in our drawings. Okay? So, we will move on to the next part of our outline. What will be the best view of conveying the information? Again, our goal is to convey information. What will be the best view in conveying the informations? The information. We have two typical general nakasanayang view na pakita na rin before ang orthographic view. Most likely it's been introduced in the past lessons. And we will be discussing what's the difference between the orthographic view and perspective view. As shown in the slide, perspective view is how we humans see the world. Orthographic view is not very normal, and we will be experiencing some a little bit drastic change when we're looking at orthographic view. Kasi nasanay tayo buong buhay natin na nasa perspective view tayo, we will experience some change, especially when we're looking at drawings in ES1. Because in engineering drawing, it is common or it's a general rule to always use orthographic view because in this view, there are no dimensions that are distorted. But in perspective view, we'll see that most of the dimensions are distorted. For example, this is a picture in a well-known building here in UP. This is what we see normally when we do perspective view. I need you to see some key characteristics of a perspective view. First of all, if you get an angle of an object, and we know in real life that the angle of this window pane should be equal with the angle of the window pane somewhere farther away. But using perspective view, we will see that they will have different angles. So I just copy paste the blue rays, and you will see that they have different angles just from the adjacent window panes only. Okay, and there is what we call vanishing point. So everything vanishes to a point in our perspective view. Okay. Okay. Oops. So in orthographic view, those vanishing points and those differences in angles vanishes. So we will not see any differences in angles. So we want to convey the information as accurately as possible. So for example, in these two views, we have red and a blue circle. If I ask you which of the um, two balls or circles or spheres are higher than another, sino mas mataas, yung blue ball or yung red ball, and I give you even 5 minutes or 1 year, you will never be able to see from this view which is higher. That's the point of orthographic view. We remove the vanishing point, we remove the feel of depth in our view. So if I remove that, we will see that the blue ball is actually higher than the red ball. Pero when I cover that picture or this step, we will never be able to know which one is higher. Because in orthographic view, we want to retain the actual dimension of our objects, even if they are very far away. Because we want to convey the correct information. Because we want to maintain that actual dimension, the depth of our view, which is common in our perspective view, actually vanishes. Okay? So all of the light rays are parallel to you compared to the perspective view. So this is the main difference of our perspective view and our orthographic view. And we will be using the orthographic projection in all of our engineering drawing in ES1. So there will be somehow a paradigm shift in how you need to see objects when they are in paper. Remember, there will be no depth. You have to rely on different views, top view, side view, and and front view to be able to know which is farther or nearer than the other. Okay? So for example, this is the common or views inside orthographic view so that we will be able to see the object clearly. First is the isometric view. So isometric view, you will be holding the object 30 degrees as shown here in the image. And this is the isometric lines and isometric axis. And if you are creating a box, this will be the angles of that box. And then you will sketch. Okay? And always there should be the length should be in the full size of the object. Again, there compared to this object, kahit picture siya, you will see that it diminishes in size. But if you're drawing in isometric view, this lengths should be the correct sizes. Everything parallel with the isometric lines, these lines, should be on the full size. For example, if this is 3 centimeters, this should also be 3 centimeters. Okay? 3 centimeters din to. Kapag gumagawa tayo ng cube, 3 centimeters din to. Ito rin. Okay? So, when we're drawing the other views of the orthographic view or the multi-view, we should be drawing the front, top, right side view to be able to know the depth. So the isometric view is a way for us to know it's like a bird's eye view of an object. While the multi-view top, front, right side view is more of a way to be able to see the object other features in different views. So when you're doing sketching, as you could see in this example, you need to know kung ito ay isometric view natin, this will be the views of those object. Okay, so if you have an object, you could now actually sketch it. You could sketch its isometric view. Just be cautious about its isometric lines and its correct lengths. And now you could draw its right side view, front view, and top view given this example. Okay? Okay. Again, these are our objectives. Okay, I'll just be skipping this because this is a joke in class, so I wasn't. Yeah, nice joke. I know. I'm skipping it. Anyway, so these are some techniques. These are some techniques of the sketching that we need to learn so that it will have some informations that we could use. So please disregard some of my notes. It wasn't really erased. So you could, sometimes it's easier to draw the negative space. So for example, this chair, it's easier to draw the negative space because they have concrete shapes. For example, this scissor, instead of drawing the scissor itself, you could draw the shapes of the negative space like this. You could draw the circle. You could draw this oval shape thing. You could draw this knife thing instead of drawing the scissors because you will be focused on those simpler shapes than drawing the scissors itself. Next is you need to maintain the proportions when you're sketching. If you're drawing, for example, this house, you could use your pencil to be able to proportion the length of the house. So for example, A to B, this is the proportion of that of this house. While if you want to get the side from A to this point, C, you could also use your pencil to be able to draw your pencil proportionally. It's like a measuring stick. And to be able to draw a good sketch, you could use your pencil as the measuring stick. Next is you could do draft lines. And you could decompose your object like this guitar into shapes. For example, this guitar, body of the guitar could be composed of multiple circles and ovals, like this one. Then from that, you could define the shape from what you've done as your sketches dictates. For example, this could be combination of two triangles like this one. Then you will just add the lines. For example, for this lamp, there are two shapes, the cylinder and the triangle with curved base. And then you will just add the details afterwards. Okay, so these are some examples of students' work before. This is an example of a keychain that is an Eiffel Tower that they made. As you could see, the dimensions are same for this base and for this base and the height. There is no loss of dimension when you're doing the isometric view as long as there's no loss of dimension as long as it is aligned with the isometric lines. The same for our top view, front view, and right side view. As you could see, it's also projected. The dimensions are also projected from top to front, front to right side view of the drawing, such that they are all aligned. Kung makita nyo yung height neto, same sa height neto, you will be able to see these things when you're actually doing the sketch. The width of the base is same as the width of the front view. So there are dimensions that are the same when you're moving from front to top, front to right side view. Okay, so this is another example of a McDonald's French fries. As you could see, The height is the same for front and right side view. The base width is the same for top and front view. And there is no loss of dimension if you're drawing according to the um, glass box. And some notes, you could use this idea when you're doing their sketches. When you're doing a ruler, you could divide the line by using the rule of your ruler. So for example, um, if you want to divide this these stairs into equal number of steps, you could use your ruler actually. For example, in this example, the lines in this ruler, if you slant it and then project those lines to the steps itself, it will be equally distributed. You could use that in your ruler. And when drawing a cylinder, it's like just flipping a coin. You could look at the coin, just look it in a different view to be able to, sorry, that cylinder, oval, be able to draw an oval. Okay? And you could do different visible lines depending on what you want to do. For example, for sharp and black, that's for dimension lines. We'll be introducing dimension lines to you next time. Medium and black for hidden lines, and slightly dull and black for visible lines, and for very light is for construction lines. So again, just an overview of the steps. Position the object that you want to draw such that there will be 30 degrees on the left and right, and then draw it isometrically. Just remember that there is no dimensions lost along the isometric lines. And then position what you want to draw. It's top view, front view, and right side view. And then you can sketch it now. Okay? And last, you could do shading to make a touch of reality or shadows of colors to your drawing. Okay. Thank you.